The SYSOUT parameter is used to designate the particular output class that we are designating to receive our printed output. This is identical to that value which is specified on the job statement as message class. As a result, we can separate out the output queues in the event that we have output that needs to be handled differently or may be destined for different output queues dependent on installation standards. If everything is standard output, you can opt to use the same class as you had specified in the message class on the job statement. So essentially what we have then is we have the ability to specify a class A through Z, 0 through 9. However, if we code an asterisk in this field, then that will indicate that we should use the same class as specified in the message class parameter on the job statement itself. The data in this situation may be destined for a physical printer, it may be destined for online viewing, or even just to be thrown away. These are all installation definitions of the particular output queues. What this value represents is strictly the output queue that the data is to be placed in. And as we said, this is going to be dependent on whatever the installation definitions are that can be legitimately used in that environment. This parameter does not exist with any of the other parameters for input or output processing. And so anything that is destined for an output queue would be specified as a sysout equals and then the class, and then there are some additional parameters that may be associated with sysout processing, but it is not compatible with any of the other definitions that would be used for specifying input or output data sets. In addition, we'd mentioned that there could be in-stream data. So this is data that basically is a part of the card image input that we are submitting. So we have JCL statements, and then embedded in those JCL statements would be input data that is to be processed by the program. Well, the way that we indicate that input data is in that stream is by coding a sysin dd asterisk, with the asterisk indicating that the data immediately follows in the next line. And in this particular case then, that means that we can use card image input to feed input into a program without having a separate data set name specified. In other words, control statements and things of that sort do not have to be predefined in a separate data set for processing, but instead they can be defined as part of the JCL stream coming in. It is in card image format, and so as a result we are limited in terms of the flexibility we have as far as the data formats themselves go. The input stream will be processed until either a slash asterisk or another slash slash indicating another JCL statement occurs. Once that occurs, the input stream is terminated and JCL syntax processing continues. So it's the slash asterisk or the slash slash that indicates the end of file for an input stream specified in this fashion. You can see in the example that we show up at the top, we have a sysin dd asterisk, and then there are two control statements. One says print active, and the other has a start equals 09, end equals 16. These are two data records that will be processed as input by this particular program. And again, once these are processed, then the following statement is either going to be the end of the job, it's going to be another JCL statement beginning with a slash slash, or it can terminate with a slash asterisk. All of those will indicate that there is no more input data to follow those two statements. In the event that the input stream itself consists of JCL, then we have another variation of that we can use where we can specify a sysin dd data, and the data indicates that JCL stream now is actually a part of the input. And so you can see in this example here, the item that is identified with the box indicates that we have data. Now, in this case, because normally the slash slash terminates the input, we had to have a special way of specifying if JCL itself was the input. And that's where the dd data comes from. In this case here then, we can use the delimiter parameter, this DLM, and we've indicated that the 2 pound signs are going to be the delimiter of the input stream. So as a result, in this case, when the system reads the SYSOUT DD data, he treats the next 4 statements then as input data. When he sees the 2 pound symbols, he says that's the termination of that input data stream, and as a result, that's going to be all that we process for input. This is not used very frequently anymore. There are some special uses to where you will run into it, but generally speaking, this was something that was much more prevalent in card-based systems when JCL itself had to be submitted either for updates into libraries or batch editing, where there was no online mechanism to go in and make changes or corrections to stored procedures in libraries. And as a result, JCL statements would have to serve as input data to be loaded into a library or to be edited. In today's environments with TSO and ISPF, we don't have a need to do that since we can go into those data sets directly and edit them. But if we still have an occasion to submit input that is JCL, we can use the DD data form of this as a vehicle for entering that data.